Alright, if I asked most developers what the difference is between an API gateway and a load balancer, I would get one of these two answers. Either a very confident wrong answer or a sort of vague hand wavy thing about they both handle traffic. And look, I get it. The names are a little confusing. The responsibilities also overlap a little, but they are solving fundamentally different problems. And if you're building anything at scale, mixing these two can actually lead up to some pretty bad architectural decisions. So let's just settle this once and for all. Before I get into the differences, I want to make sure we are starting from the same place. Both of these tools sit in front of your backend servers. Their job is to deal with incoming network traffic, so your actual application servers don't have to deal with every single complexity of the outside world. And think of them like bouncers, or more really like a well organized front desk at a huge office building. But what they're doing behind that front desk is completely different. And that's what we are here to unpack. Okay, so let's start with the load balancer because it's conceptually a little simpler. A load balancer has one job and it does that job really well. It sits in front of a bunch of identical servers and distributes incoming requests across them. That's it. So, why do we need this? Because if you have 10 servers and all your traffic is hitting server 1, servers 2 through 10 are just sitting there doing nothing while server 1 is on fire. A load balancer makes sure the load, as in the actual compute load, is spread evenly. It's operating mostly at the layer 4, which is the transport layer, meaning it cares about IPs and TCP connections. It doesn't really look at the request and go, what's in this HTTP body? It just routes. That's the only task of a load balancer. That's it. Now, there are different strategies a load balancer can use. For instance, we have round robin, which just takes turns. We have least connections, that is, it sends the next request to whoever's least busy. Then we have IP hash, that is, it always routes the same user to the same server. So it is pretty useful for sticky situations. And most modern load balancers are also doing health checks, like constantly pinging your servers to make sure they're alive and automatically pulling them out of rotation if they're not responding. So what's important to notice here is that the load balancer is thinking about servers. How many requests is each server handling? Is this server healthy? It's not thinking about users or authentication or which microservice this request should go to. Okay, so now we've got the load balancer down. Good at one thing, distribute the load. Now here's where it gets more interesting and honestly more nuanced as well, because the API gateway is completely different category of tool. It's not just a load balancer but smarter. It's solving a completely different problem altogether. The load balancer is thinking about infrastructure. The API gateway is thinking about your API. Keep this in your mind. An API gateway is aware of your application layer, that is the layer 7 in OSI terms. It actually reads your HTTP requests, it looks at the path, the headers, the body, and because of that, it can do a whole bunch of things that load balancer can't even touch. First is authentication, that is, it can check does this request have a valid JWT token or not before it even hits your server. And next, it has a rate limiting, that is, this IP has 500 requests in the last minute, so we got to slow down. So it has that capability as well. Then we have routing, that is, this request is going to slash users, so send it to the user service. This one's going to the slash payments, so route it to the payment service. So we have that functionality. Then we have request and response transformation, that is, it can even reshape the data between the client and your backend. So this is the tool that makes microservices actually manageable from the outside world. Now let's make this a little concrete. Say you're building an e-commerce app. A user opens a mobile application, they're logged in and they've hit view my orders. Their app fires a get request to your API. The request hits your API gateway first. The gateway checks that does this request have a valid auth token or not. Yes. Is this user being rate limited? No. Okay, where does this request need to go? The path says slash orders. So it routes it to the orders microservice, not the user service, not the payment service. The order service does its thing, sends back a response, and the gateway can even clean that response up before sending it back to the client. Now, the load balancer isn't even in this picture yet. It might be still sitting behind the gateway in front of multiple instances of order service, making sure none of them gets overwhelmed. But that's a completely different layer entirely. So let's just put them side by side. Load balancer is in layer 4. It cares about IPs and TCP, distributes traffic, doesn't know what's in your request, and doesn't do the auth and all. And API gateway sits in layer 7. It reads your full HTTP request, routes based on content, handles auth, rate limiting transformations, different tools, different jobs, and honestly, most production systems use both. You'd put the API gateway at the edge to handle all your application layer logic, and then behind it, in front of each microservice cluster, you would have a load balancer distributing the traffic across multiple instances of that service. Now, this is what a real production architecture often looks like. Clients hit the API gateway. The gateway handles all the smart stuff like routing, auth, rate limiting. Then for each service, you've got a load balancer in front of however many instances you're running, making sure none of them gets overwhelmed. They're not competing with each other, and they are doing completely different jobs at completely different levels of the stack. The gateway is about API intelligence. The load balancer is about infrastructure resilience. So we need both of them. Let's take a quick practical detour. What are people actually using for each of these? For load balancers, we have AWS ELB and ELB, which are super common. We have HAProxy, which is classic. NGINX is everywhere. GCP and Azure both have their own. For API gateways, we have AWS API Gateway, obviously. Kong is huge in enterprise world. Apigee if you're deep in Google ecosystem. Traefik and Envoy in Kubernetes heavy setups. And here's the thing, NGINX shows up in both the lists, which is kind of a perfect illustration of why this gets confusing. NGINX can be configured to act both as load balancer or an API gateway or a reverse proxy depending on how you set it up. The tool can do multiple things. Before I wrap up, I want to call out a few mistakes I see pretty often. First, trying to do auth or routing logic inside a load balancer. It's not built for that. You end up hacking around it or building something fragile. Second is that using your API gateway and skipping the load balancer entirely. Your gateway can route to multiple servers, sure, but it's not optimized for that. As you scale, you'll actually feel the pain. Third, this one's a little subtle, that is duplicating gateway logic across services. So each team builds their own little mini gateway. Now you've got auth logic in 10 different places and you're maintaining all of it. That's why centralized gateways exist. Put the cross-cutting concerns in one place. Alright, so here's the thing to remember. API gateway, it is smart, application aware, handles your cross-cutting concerns like auth and routing. Load balancer, it is focused, infrastructure aware, keeps your service from tipping over. They're not competitors, they are teammates working at different layers. That's it. Once you see them this way, a lot of architecture decisions get way clearer. If this clicked for you, drop a comment, specifically which one confused you more before this video. I read those and it genuinely helps me to know what to cover next. See you in the next one. Thank you.